When working on a new or improved sound system for a client, my specialty is in the design and commissioning and tuning phase. In the middle, there is an integrator, or at least a party responsible for hanging the system, running all the cabling, connecting it all together, and that's not something that I do. I'm in the very beginning and the very end. An integrator, or maybe someone who's on staff at the church who's pretty handy, or someone who works for the venue part-time, whatever, they're all going to be a part of the equation, and I want to make sure we are on the same page. So to ensure that, I've created my sound system commissioning checklist, and this is something available to you for free in my audio toolkit at the link below. You can snag that and tweak it to your liking, but it's here so I can create alignment. I don't like babysitting people. I don't want to tell the integrator how to do their job, but I do want to give them clear guidelines of what it looks like to work with me. So here at the first half of the document is the integrator order of operations, and the back half is the system engineer order of operations. Basically, what I want the integrator to have done before I or the system engineer that I hire to go tune the system gets there, and then what is the system engineer responsible. And this does two things, and make sure we are clear on the front end so they know what to have ready and done, and it also helps my client understand that we're working together as a team for their common good to get their goal across. So what I'm going to be doing in this video is walking step by step through each of these, the thoughtfulness, the why behind each of these, and all along the way showing you deliverables from a real project I'm in the middle of right now, and how I'm stitching together these assets to make it clear for the integrator that I'm working with and making sure my client is served well. I'll be going out to tune their system in about a month, so it'll be fun to report back and see how it went. But I always want to do my best to show you real world scenarios and how this is playing out. All right, so let's start at the beginning and step through this document. I've made it within Notion. If you are a Notion user, you can go up and actually duplicate this and use it as a template. If not, you can still view this as a web page in my audio toolkit at the link below. Copy and paste anything from it. Please feel free to take anything you want if you find it helpful. You can navigate it with a table of contents at the top. You can easily skip to any part of it if you want, or it can just serve as a reference. Otherwise, you can just scroll and look at the checkboxes. So with the integrator, make it clear what the integrator is responsible for before the system engineer arrives. So here's the pre-flight. So always reference the project map for most up-to-date design documents and settings. So how I deliver everything to my client and the integrator is right here, what I call a project map. So this is nestled within the project, and we can actually link back to the sound system tuning commissioning checklist here at the top. But here I have a walkthrough video of the design to make it clear where each box is going and why and their angles, and that's detailed out more here in the system report. So within Ease Focus 3, I can render out a system report that shows the SPL map, and this is the broadband A weighted, and see the entire system was within plus or minus 3 dB, which I think is a good definition of success. It shows that 98% of the audience is within that coverage, which is awesome, less than a dB and a half of standard deviation, and it lists the speakers that I have. So we can look at each one and see that there's a balcony relay, there's a center fill, there's a house left main, house right, and this gives them their positioning and their orientations and their relative gains. Of course, I'll adjust that all on site, but anything from a positioning standpoint is detailed out here in the system report, and then they can also see that further in the design overview. So that's already always at the top. And let's say there is a V1, we've changed something, I'll go ahead and film a V2, post that there, and then put in the system report V2 if we make any changes. And I'm using a Linear Research amp and DSP combination on this project, and that is within System Engineer. I have that design already made. So the integrator, all they have to do is load up this .dse file into the Linear amp, and it already has it. So I've spec'd a Fulcrum acoustic system, which I've got that design file here. Go through that a little bit more slowly. And it is a center speaker covering the main floor, 60 by 45 CCX, which means it's their subcardioid box. And then I have a flown sub right behind it. Then I have two side, almost more like downfills to get these first few rows right here and here, and then the center main is responsible for most of the floor. And then I have a relay that's covering the balcony by itself, and it's a 120 by 60 degree box, so it is very wide. So that's the main elements in that. And then we also have two choir monitors that will be nestled right here and right here facing in. And those are on this version of the design document, but those are going to be the RX 699s, which are 90 by 90 little cute 6-inch boxes that will be back there. So the choir can hear be on an individual monitor mix. So that's a look at the project itself. And if we cruise through the rest of the project map, I just showed you that the amp preset is right here. And this is what it looks like loaded up within System Engineer, and that's all I got to do. I'll take over from there once I go to tuning, of course, with them to verify it. And then I also have a line diagram. So this is made within Whimsical. It's a new tool to me. I've been using it less than 6 months now, but it's more like a mind mapping or a website SketchUp tool, but it's been really cool to create iterative line diagrams. So in this particular venue, they have an X32 hooked up to a Behringer S16, and we only need 4 outputs. I listed those here. So I got mixed left, mixed right. Then I have detailed out female XLR to Phoenix connector, since it is terminal block or Phoenix connector on the Linear Research LR88C10. And I've posted what those outputs look like, or a picture of each, so then they can easily see, hey, here's the analog audio inputs. Those are indeed, terminal connections or Phoenix blocks, and then the outputs of the amps are not terminal strips, they are NL4. So then I have each of the 8 analog ins, only using 3, but then the outputs, at least on this amp, they share outputs. So 1 and 2, or channel 1's on 1 hot, 1 cold, then channel 2 is on 2 hot, 2 cold on that NL4, and it keeps going through. And this details out, hey, I want 4 conductor NL4, and then have an NL2 breakout, 1 going to the center main, 1 to the center sub, and that's reflected in the DSP file here. And then I say, hey, feel free to use NL2 breakouts at the amp, then run 2 separate runs if that's easier. So again, I'm going to defer to the integrator at this point to execute it how they want. But this is the I/O map of the amp itself. Again, 4 conductor NL4. Same thing, this run could be with 2 conductor cable, but I specify I still want 4 conductor just in case they add a relay sub or have another speaker in the future. And then those are the house left choir monitors. So I try to make it as clear as possible and leave as little up to chance in this document. And I like Whimsical because I could update something here and it's always up to date in the web link. And that's why I want my integrator always go back to the project map, because everything is housed here. And I can say, hey, if it is here, it's going to be up to date. And let's say they still want to reference something. I can just do a little toggle list right here and just call this archive. And I can click and drag this into it. And now I have everything that I did deliver here, but it's in an archive. But right now, this is all on V1 and would live here. So this is just one trusted public web page that, it's not indexed in a search engine, but the integrator and my client can have access to it at any point, see where we are at. And actually, one of the first deliverables I have is the last one here, and that is the gear list. So that's each of the speakers, what they're there for, the quantity. I have another sheet with pricing on it, and so just so they can see in total what I'm asking them to get to pull it off. And then this is where my integration part of it stops. I'm just saying, here's the gear list. You purchase it however you want. You get it through the integrator, you buy it yourself. It doesn't really matter to me. My business model is the strategy on the front end and the commissioning at the end. But just make sure here are the exact model numbers and what I need to pull this design off. All right, so that is the project map, so you just have a feel for what's going on. But what I expect from the integrator is to have all speakers placed and aimed according to their design specs, so you can trust that whatever I've asked you to do in the system report, please make sure that is so. All rigging hardware fastened to secure properly, so just to make sure that things are going to stay in the air. Then all cabling runs executed as orderly and neat as possible. Again, good integrators are going to do this anyway, but just want to make that explicit just to make sure everything stays clean. Moving on to wiring and control, all cables clearly labeled with patch name or number legend, which can be traced to a master cable run document and easily identified. Sometimes there's few enough cables where you can literally put on the sleeve of it or any label on the cable, okay, mains left. But if it's a giant system, that gets a lot to print out, so they'll often print out a number scheme that can be traced back to a document. So either way is fine with me, just make sure that it's clear. And then all cables verified for proper polarity and continuity. This is the biggest thing I end up sniffing out on installs after I end up going through and testing every speaker is that sometimes the NL4 gets wired backwards or the pin's reversed, and or the XLR for that matter, into active speakers, and the polarity is inverted. So make sure through the speaker with an analyzer, verify that, and that will then also check for continuity. So make sure signal can pass all the way through the cable at the level we want it to the speaker. And then all gear has most recent firmware updates successfully installed. So that's all there so that we're not missing a feature, any mismatch between my DSP preset file and what's happening in the amp. DSP and amps all on local network with an Ethernet line or switch available at front of house. Most of the time I end up setting up my tuning world at front of house or having a machine that can access it there. So I want to be able to make sure I have access to it. DSP and amps are sent to link local or getting a self-assigned IP, usually in the 169 range, or have received an IP from a permanent DHCP server, which is usually within the house router, or have clearly documented static IP addresses. Again, any method is okay with me. Just make sure that it's clear and I can quickly get on the network. If you're using static IP addresses, please reserve 2 IP addresses for my machines so I can get on the network and make changes to the amps and DSP. And then DSP or amps are unlocked and have no password set. This is usually the case if I'm coming into a currently installed system and making changes, not a new install. The integrator thinks they've done a favor and I've locked out the DSP and I've traveled all this way and can't get into it. They have to do a factory reset or call up people. That's no fun. So definitely have that done. All digital patching via Dante or similar protocols have been clearly labeled in their patching software. So just like in Pro Tools, if you record something, it shouldn't just be audio 1, audio 2, audio 3. With patching, it's great to have each device labeled, but then the output and input channels on each device clearly labeled, especially if it's a larger network. And lastly, on wiring, please provide XLR inputs available into the DSP for the tuning rig signal generator. If the DSP has Phoenix connectors, please have 2 Phoenix female XLR lines terminated or 2 turnarounds provided. Again, the unit we're using on this particular gig for both the amplification and tuning is this Linear Research amp, and it has terminal blocker Phoenix connector inputs, and the output of my interface is actually TRS, and to an XLR cable, I need to be able to get in here, so have XLR lines terminated. Moving on to processing in presets, the DSP config file has been loaded into the processors and or amps if they are separate units. So that would be located here in the project map. And there I will list out the separate files if they're loading into different amps that are different parts of the system or a different processor. So I have those loaded up and ready to go. Next is to monitor gain structure and metering across all inputs and therefore outputs. Make sure they're consistent. So when you're sending a 1K sine tone, maybe through a signal generator or SoundBlend or what have you, make sure that the meters are telling you the exact same thing on every input, just to make sure everything's wired up correctly. And lastly, on processing presets, test any failover inputs or outputs. So whether this is a Dante primary to secondary, whether this is Dante over to analog or AES or AVB over to analog, whatever the system infrastructure is, if it has a failover, test it and have it ready. Moving on to audio verification, let's test all active inputs and outputs, ones that are going to be used with the system, but then just as important, test any inactive or unused inputs and outputs. And this is to make sure that any future expansion, everything is ready to go, or there might be a guest console that comes in and those inputs on the DSP aren't used very much, but you want to make sure they are available. So anyway, make sure every single in and out on the system is tested on every single piece of gear. Lastly, have all the same model speakers with the same magnitude and phase response and level when driven equally. If at all possible, before you get them in the air, assuming they're going in the air, do a ground plane measurement. And have a link to a video here on how I did this with a QSC KLA 12 system. This is a ground plane measurement, very similar to how it's done for Tracebook. So if you want to look at Tracebook's measurement capturing guidelines, do that. But this is basically just to ensure that every speaker is doing the same thing. And so what this might look like is pulling up Smart. These are the traces from that. So I took all 10 boxes that were going up in the array, put them on the ground, drove them with the same signal at the same distance from the microphone, and this is the measurement I got. And so they all had the same phase response, all had the same magnitude response. So therefore, they are in good shape. So do this with your gear before you get it in the air. So post-flight, last thing for the integrator is to let the project manager and system engineer know if you run into any issues or have any questions. So if anything on this checklist doesn't make sense, please don't hesitate to reach out and make sure you can get this done before the system engineer arrives. Now moving on to the system engineer order of operations. So maybe you're looking to do more install gigs or tune systems, and this is just as much a reminder to myself to make sure that these things are all done, because it's a lot to keep up with. You want to make sure it's done well. This helps know that I can, show my client that yes, all this was checked off, you're in good hands. So the project drive link is accessible, so I keep everything in a Google Drive folder. So if I clicked on that here for this project, everything would be housed here. Next is the project map link is accessible. So that's here. So don't worry if you're not a Notion user, you can still access everything. I can just edit here since I'm using it within Notion. Then the appropriate system design software installed. So if you're working on a system that's within ease, like this one is for Fulcrum Acoustic products, have that. If you need a RayCalc, Map3D, whatever, just have that ready to go so you can pull it up before you get there. Then have any appropriate DSP or amp control software, so whether that's System Engineer, R1, Compass, whatever it is. Just take note that sometimes it's either Mac or PC only. So if you only have one type of device, make sure you can either run Parallels on a Mac or just go ahead and buy a PC. Then have a local copy on your machine of the following files found in the drive folder. And why I say local copy before arrival is to make sure that just in case you get somewhere without internet access, you can have everything you need. So if that's doing it in the airport terminal before you go there, that's great. But having this, so this the gear list, the system design file, the system report PDF, the line diagram, and the DSP amp config files. Again, these are basically all the assets that are listed here in the project map. So either take a screenshot of what you need, download this PDF entirely, whatever, to make sure you have a local copy. And then have the following gear with you. So your audio analyzer of choice, whether that's Smart, Systune, Open Sound Meter, Crosslight, whatever you want, an audio interface, and at least one measurement microphone. And then have your XLR cabling or wireless setup needed for your rig, including longer cables to run mics. The only thing I like to ask of my clients are mic stands, and I'm even now buying some of those smaller Manfrotto stands, so you don't even have to ask that. But if you're working on my behalf, that's the only thing I want to ask of clients is mic stands. So bring all the other gear with you. Moving on to verify is verifying the placement and aim of every speaker in the system as guided by the system report or design. So you can't always do this super exactly if you can't actually get up in a lift and do it, put a laser on stuff. So if a lift is not able to be on site, just eyeball it, look at where things are aiming. If there's any huge discrepancies, we can ask the integrator to change that. You will, of course, be measuring the system soon and maybe asking for some changes anyway, but just give everything a once over before you start tuning. So connect computer to local network and load appropriate DSP amp control software. Hopefully the DSP files are already in the amps, but you'll need to push those if they did not get loaded. Then verify initial DSP amp settings are correct, rectify that if not. And then last step of verification is to take solo on-axis measurements of every speaker in the system, checking for balanced levels across like speakers, polarity, expected frequency response, and referencing against near-field measurement, a GLL file, or verified tracebook.org data. So this is basically just a more detailed look at what the integrator should have already done, verifying that every speaker was matching. But we're making sure that's the case with them in the air, and we're taking into account the entire drive line. If the integrator's checking for each speaker on the ground in isolation with that tested system, once the speakers are in the air, that's different cabling that's ran, that's probably a different amps output, and we want to make sure everything is the same across the board. Now moving on to tuning. Of course, tuning is more than just 4 steps, but just broadly speaking, you're going to end up level setting each zone, verifying the speaker coverage, balancing the system response with EQ, and then timelining each PA zone. That's tuning in a nutshell. But how you go about that, your own specific workflow process may be different than mine, but as long as we end up at a good result and a good sounding system for the client, great. Listen and finalize. Let's play some reference tracks through the PA, walk all the zones, take any notes, do it with the client after you already done a walk, ask some questions. So work with the client to shape the system tonality to fit the client's goals and the system's acoustical environment. If this is a church that likes a ton of kick drum and they want the low end 20 dB above 1K, so be it. Let's boost the subs. If it is a jazz bar, they're not going to need that much low end, so account for that. Moving on, capture a trace at front of house mix position and compare against the audience average. So if you've hopefully, as you've tuned, taken a bunch of different measurements across the audience, we can roll that into an average, at least with the main systems, and hopefully the fill systems are acting the same. We want to make sure see what it looks like at front of house to note any discrepancies, because sometimes we may need to put some near field monitors at front of house to restore some top end, or you very well might be in a closet somewhere mixing instead of the room. So capture a trace and see what the discrepancies are. Can they be rectified? Have that conversation. And lastly, determine optimal DSP or amp input gain structure from the front of house desk. So each mix engineer is going to want to run their console at a different level. Some just want to be able to set gain structure on their channel strips coming in and then shade down their master fader to fit the system. Some want to be able to run their output hot, then you eat the gain, because more often than not, unless you're running a really loud rock show, you're going to not need the system at full tilt if it's properly spec'd. So I would advise that if they want to run the console hotter, you use the inputs into the DSP and bring those down to eat some of the gain. That way they have more room on their outputs. Especially on corporate gigs, folks end up using their gain pot to get the lavalier microphone up to -18 or 0 dB VU on an analog desk. And then they start to push the fader up and they're only at -20 and it's feeding back. And so they have to bring down the gain of the system somewhere, and that's usually done at the DSP inputs. Okay, lastly, after you're all done, the post-flight is to basically save everything. So the finalized DSP amp configurations, save it to the local or device network, and then save a copy of it to the Google Drive folder I mentioned earlier, which you'll have access to if you are working for me, or I'll do that myself. Or save a copy of the console file to drive the console file, because sometimes, depending on the install you're on, what the console is doing, it dictates some of the gain structure or routing, where maybe had to use a few of the matrices on the desk to feed some weird zones that were somewhere in the system. So we want to capture that as well. Save a copy of all the captured analyzer data, just so we can look at before and after of the data and verify we did our job. And then deliver a copy of all this to the client. And then lastly, get your phone out, do a little walkthrough video of the entire rig with some music playing, and verify that everything is as it should be, just so for any liability later on, saying like, hey, we did the job, this is all done, the client can sign off on it, and away we go. All right. Thank you for sticking around. If you're still here walking through this checklist, this is just to make sure I have alignment with the integrator and the client to make sure we're on the same page and getting the right things done. What I would love to hear from you is, what am I missing? What is not in this checklist that should be there? Or what was a good aha moment or something you're going to steal and use on your next project to make sure you get it done right? My name is Michael Curtis. I love helping you make sure it sounds amazing in every seat. Appreciate you watching. I'll catch you next time.